Hi guys, this is Jonathan Lambert of the Mathematics Development and Support Service at National College of Ireland, and in this short video, another video in our series of videos dealing with probability theory, we're going to have a look at an example calculation using Bayes' theorem. Okay, but first let's maybe actually just give you the theorem itself with respect to Bayes' theorem. Actually, let's just develop it again from the multiplication rule. So we know that the multiplication rule, okay, says that the probability of A and B happening is the product of the individual probabilities. It's the probability of A times the probability of B, knowing that A has happened. This is our conditional. Okay, actually, when the two events are dependent on each other, okay, we have to calculate the conditional probability of B given A. When they're independent, this actually just reduces down to the probability of A times the probability of B. But I mean, if they were independent, this would reduce down to just the probability of B. So it's okay to have it in this form. Now we could flip these two. We could say, well, what's the probability of B and A happening, which is the same question. And in this case, we get it's the probability of B times the probability of A, knowing that B has occurred. Okay? And these two things should be equal. Okay, so we can equate here. So now we have, so therefore we have that the probability of A times the probability of B given A is the same as the probability of B times the probability of A given B. Okay, and now what we can have here is we can have, so here we have, if we just solve for this conditional probability, we have that the probability of B given A is the same as the probability of B times the probability of A given B divided by the probability of A. Okay. Now these are just placeholders, these A's and B's. Okay. But what we might want to consider is the concept of a hypothesis. Okay, a hypothesis. Let's symbolize that by H and data. Okay, so from the data we have, let's say we symbolize that by D. So another way to actually write Bayes' theorem from a hypothesis data perspective is that really typically what we're trying to figure out is that we've observed some data in the real world. Okay, we've observed data in the real world, and we want to know, well, what's the probability that a particular hypothesis is true, knowing that we've observed the data. That makes sense. So Bayes' theorem then would be rewritten. Okay, so we can let's say we can write Bayes' theorem using H and D to represent hypothesis and data. Okay, so what we really want to calculate with Bayes' theorem, we don't want to calculate. There's two probabilities we can calculate: the probability of the hypothesis given the data, or we could calculate the probability of the data given the hypothesis. Actually, this thing here is null hypothesis significance testing. Okay, so we're not going to do that. Okay, we're going to use the Bayesian approach. Okay, Bayes' approach, which is I suppose it's an alternative to this approach here. It's more intuitive. It's probably what happens in the real world. We calculate probabilities. We calculate probabilities of hypothesis based on things that we see, data that we see around us every day. Okay? We don't really make hypotheses and then go off and measure and see whether the data agrees with it. That's not really what happens in the real world. Well, it does for the scientific method. Okay, but when you're walking down the road, you see things, and then you make belief. These things that you see helps you to form beliefs with respect to the world around you. So that's where Bayes comes in. So rewriting this, we're really interested in this here, to be able to calculate these things. So we're interested in the probability of a hypothesis being true, knowing that we've seen the data. Okay, so this gets rewritten then. Okay? This gets rewritten as, H is going to be B and D is going to be A. So this gets rewritten as the probability of the hypothesis times the probability of the data given the hypothesis, divided by the probability of observing the data. Okay? So this is the rule that we're going to use, this particular rule here, okay, to explore Bayes' theorem, or the application of Bayes' theorem in a little bit more detail. And what I'd like to consider is two possible situations that a doctor, okay, so two situations, let's say situations, okay, that a doctor, okay, might be confronted with, okay, might be presented with. And actually, this particular example that I'm going to use has been taken from James Stone's text, which is Bayes' Rule, a tutorial introduction to Bayesian analysis, which is a really, really good book. I'd highly recommend it. So it has been taken from Stone. And let's use this because I think it's a really nice example that sort of gets across this idea of Bayes' theorem. Okay, so let's keep this in mind because we're going to use this particular formula. Okay, and let's just give you some. Let's just set the scene. Let's